Okay, guys, settle down, please. So this is probably the last session of the year. So not very high yield development of the eye and ear. We just will go briefly through the development of the eye and ear. It's a very specialized area. We will just go into a brief embryological development of both these structures, eye and ear, and you already know the anatomy of the eyeball as well as the parts of the ear. So I would assume that you understand the basic structure. So we'll start with the development of eye, and the developing eye basically starts to develop around the 22nd day of development, and it is basically developing from the brain, and you have these at the diencephalon, because the neural tube is formed, so you have diencephalon, and from the diencephalon you have these vesicles which are going to arise, and this is called the optic vesicle. You can see this is the 22nd week, and around the forebrain you have this optic vesicle which is arising from where your diencephalon is, where your thalamus and hypothalamus is, the forebrain part. That's the place from where the optic vesicles are going to arise, and they are going to move towards the surface ectoderm. So if you see here, this is the neural tube, this is the forebrain. You can see that optic vesicles are arising and they are moving towards the surface ectoderm. As this optic vesicle is going to touch the surface ectoderm, it is going to start to invaginate. So what you are going to have is that this optic vesicle, as it is going to touch the surface ectoderm, it starts to invaginate. So it would have an outer layer, it would have an inner layer, and it would have a groove underneath it, which is called where the hyaline artery is going to run. And as these two lips are going to come together of the optic vesicle, it is going to give rise to the pupil. But it also does something else. As this optic cup, which is this optic cup, this is the optic cup. As it invaginates, it becomes, the optic vesicle becomes the optic cup, and the groove under it is the hyaloid groove where the hyaloid artery is running. It is going to stimulate the surface ectoderm to produce something else, which is called the lens placode. And this lens placode is going to detach itself after a while from the surface ectoderm. And because it is lying just behind the lips of the optic cup, so it's the pupil, and behind this is the lens placode, which is going to give rise to the lens. Everybody understands this? So you have optic vesicle coming in contact with the ectoderm, and the contact of the optic vesicle with the surface ectoderm induces the lens placode to be formed. Lens placode invaginates and develops into the lens vesicle, and during the 5th week the lens vesicle loses contact from the surface ectoderm, and it is going to lie within the cup, the optic cup. The lens vesicle lies in the mouth of the optic cup, and this lips of the optic cup, when they are going to fuse, they are going to give rise to the pupil. So what is going to happen with this, the optic cup, because it has an outer layer and it has an inner layer. So the outer layer of this optic cup is going to give rise to the pigment epithelium, and the inner layer of this optic cup is going to, the posterior 4/5 is going to form the pars optica retina. And this pars optica retina is going to give rise to the rods and the cones. So the outer layer is mainly responsible for the pigment epithelium. The posterior 4/5 of this outer cup is going to give rise to the pars optica retina, which gives rise to the rods and cones. The adjacent mental layer is going to give rise to the neural part of the retina, which is the bipolar cells, the outer inner layers of the retina. They are all going to give rise to the neural retina. So, and that's why you see the gap between the pigment epithelium and the neural epithelium, and that's where the retinal detachment happens. Because embryologically, the outer part of the retina, which is the pigment epithelium, is basically arising from the outer layer of the cup. The inner layer of the cup, which is mainly giving the neural retina, there's a gap between them. And that gap is a potential space in which you can have the detachment of the retina. So you can understand here the pigment epithelium, the outer part of the cup is giving rise to the outer retina. Then you have the mental layer, which is giving rise to the neural retina. And then you have the innermost layer, which is going to give rise to the fibers of the optic nerve, which are going to form the optic fibers or the axons of these neural retina, which are going to give rise to the optic nerve. Now, before we go, as we move forward, so this is about the posterior 4/5 of the cup. So 4/5 of the cup, the outer part is giving pigment epithelium, the inner part is mainly giving the neuronal layer, which is going to give rise to the nervous retina. There's also the continuation of this cup forward, and that anterior 1/4, which is of this cup, is going to give rise to some other parts, and these are mainly the anterior 1/5 of the inner layer forms the pars ceca retinae, which gives rise to divides into pars iridica retinae, forming the inner layer of the iris, and pars ciliary retinae, which participates in the formation of the ciliary body. So the inner layer of the retina, which is forming the inner part of the retina, is moving forward also and participating in the formation of the iris and also the formation of the ciliary body. So your sphincter, dilator, pupillae muscles are basically ectodermal in origin, because they are coming from this the posterior part of the retina, which is moving forward. The inner part of the cup, as it moves forward, is going to give rise to the iris, and it is also going to give rise to the ciliary body. So both these muscles, although these are muscles, sphincter pupillae and dilator pupillae, they are ectodermal in origin, while the ciliary muscle is mesenchymal in origin, which is mesodermal in origin. So this is the only important thing here to remember, that the sphincter and dilator pupillae muscle are ectodermal in origin, because they are basically the continuation of the inner part of the cup. As it goes forward, it is going to form the iris and the ciliary body, and the iris and ciliary body has these two muscles. One is the sphincter pupillae and dilator pupillae, both are ectodermal in origin, while the ciliary muscle, which is a part of the ciliary body, is arising from the mesenchyme, which is mesodermal in origin. Now, we have made what? We have made the lens, which is coming from the lens precord, which is the surface ectoderm. We have made the retina. The outer retina, which is the pigment retina, is from the outer part of the cup. The part of the cup is giving rise to the neuronal layer of the retina. And then this neuronal layer is moving forward and giving rise to the iris and the pupil, iris and the ciliary body, and the two muscles, the sphincter and dilator pupil. The ciliary muscle is a mesenchymal innervation. Now, if you remember your eyeball, you would remember that there are three coverings of the eye. One is the outermost is sclera, then you have choroid, and then you have the retina. Okay? So the two other layers have to be formed. So there is mesenchyme around this optic cup. You see this? Mesenchyme around this optic cup. When this optic cup is forming, there is also mesenchyme around it. This mesenchyme around the optic cup is going to give rise to the choroid, which is the vascular layer, and the sclera, which is the thick opaque layer of the eyeball. So end of the 5th week, eye primordium surrounded by the loose mesenchyme, and this mesenchyme differentiates into two layers: inner vascularized pigment layer, which is the choroid, and outer layer, which is the sclera, continuous with the dura mater of the optic nerve. So this all mesenchyme, which is around the optic cup, is going to give rise to the choroid, which is vascular, inner vascular layer, and outer thick, opaque layer, which is the sclera. Now the cornea here, which is usually 4/5 posterior part is all sclera. The anterior part is transparent like a lens, which is the cornea. So that cornea does not come from this mesenchyme. It comes from the epithelium of the cornea is going to come out from the surface ectoderm. So the surface ectoderm is also going to give rise to the epithelium of the cornea. So cornea is not coming out from the mesenchyme. It's coming out from the surface ectoderm. Okay. Now, what we have made the sclera, we have the choroid. We know that the optic cup itself, the outer part is making pigment epithelium of the retina, inner part is making the neuronal layer of the retina, and then this neuronal layer, as it moves forward, is going to give rise to the iris and the ciliary body. And the cornea is coming from the surface ectoderm. So what is left? You also have made the lens from the lens blackboard, which has come from the surface ectoderm. So behind the lens, what it is? Vitreous humor. So how the vitreous is going to come? So this, the mesenchyme, which is around this optic cup, you remember that there was a hyaloid groove at the bottom. You're looking at it from the outside. It's like a globe, but there is a hyaloid groove in the optic cup, which is running on the bottom. So through this hyaloid groove, the mesenchyme, which is surrounding the optic cup, is also going to go inside. As it is going to go inside, it is going to form the vitreous. So the mesenchyme surrounding the eye primordium from outside also invades into the optic cup via choroid fissure, and this invading mesenchyme forms this vitreous body, and that's why the hyaloid artery, which was going all the way here, is going to degenerate. Its distal part is going to degenerate. The proximal part would be left, and this hyaloid groove is going to completely close. As it is going to completely close, there will be a tunnel inside this, because this is like it was a groove like this. So there is a bottom groove. As it is going to completely close, there would be a tunnel inside it. This tunnel will contain an artery, which is called the central retinal artery, and the whole thing will, the primordium, which was moving forward from the forebrain, this stalk, the optic stalk, is going to become the optic nerve. So the optic stalk, which is coming from the forebrain, is going to become the optic nerve. The hyaloid groove is going to close, become a tunnel, and the proximal part of the hyaloid artery will remain, and that will convert into central retinal artery. Clear, everybody? Okay. So the optic cup connected to the brain by optic stalk has a choroid fissure on the ventral surface. During the 7th week, the choroid fissure is going to close, forming a tunnel inside the optic stalk, and the optic stalk transforms into optic nerve, and in the tunnel, the artery, the proximal part of the hyaloid artery which remains, is going to be called now the central retinal artery. Okay? So what we have made, we have initially the optic vesicle. This optic vesicle, when it reaches the surface ectoderm, it arises from the forebrain. It moves towards the surface ectoderm. As it touches the optic, the surface ectoderm, it starts to, go inside, forming an optic cup, or invaginate, forming the optic cup. It also induces the surface ectoderm to form the lens blackboard, which get detached from the surface ectoderm around 5th week to become the lens blackboard, lying in the hollow of the cup. The cup has two parts. It has an inner layer and an outer layer. The outer layer is making the pigment epithelium in the posterior part. The inner layer is forming the neural retina. The anterior part of the inner layer is going to give rise to the iris and the ciliary body. And as the lips of the cup are going to join together, they are going to form the pupil. And because behind this is the lens blackboard, which is going, or lens vesicle, is going to give rise to the lens. Then you have the sphincter pupillae and dilator pupillae muscle arising from the ectoderm, and you have the ciliary muscle arising from the mesenchyme. The mesenchyme surrounding this optic cup is going to give rise to inner vascular choroid and outer thick sclera, and the anterior part of the surface ectoderm is going to give rise to the epithelium of the cornea. So it's not the optic cup itself which is going to give rise to the cornea. Then we have the choroid fissure on the ventral surface of the optic cup, and this choroid fissure will allow the mesenchyme to get into the eyeball, giving rise to the vitreous. As the optic stalk choroid fissure is going to fuse, it is going to form a tunnel in the optic stalk. So the posterior part of the optic stalk is going to become the optic nerve, and the proximal part of this hyaloid artery, which was running in the choroid fissure, will become the central retinal artery. So this is a brief, description of how different structures of the eyeball are developed. Now we have some abnormalities. So one of the abnormalities which you see is called synophthalmia, which is a rare congenital abnormality characterized by partial or complete fusion of two embryonic eyes. So as the optic vesicles are developing, rather than becoming two vesicles, they join together and they do not separate. So you have only one single eye. This is synophthalmia. Results from the failure of normal separation of optic vesicles during the forebrain development.
Doctor, is this compatible with life?
Usually not, because holoprosencephaly also happens. So you don't have two lobes of the brain, one lobe of the brain. So those are the midline type of abnormalities which happen. It's a very rare abnormality, and it's a very deadly type of abnormality which can happen. Now we are coming to the development of the ear. So as we usually do, we do the external, middle and internal. we will now start with the internal ear development and then go to middle and then external. So rather than going from the outside, we are just going from the inside. So if you remember, the eye was developing from the forebrain. The optic vesicle was coming out from the forebrain, and then it became the optic cup and all those type of things which we talked about. It was coming out from the forebrain, and it reaches and hits the side of the surface ectoderm, and we call it optic blackboard or lens blackboard. Sorry, lens blackboard, because there was, when it touches the surface ectoderm, lens starts to form. So there was a lens blackboard on the side of the forebrain. Now here what is going to happen is just lateral to the rhombencephalon. This is the neural tube, and just lateral to the rhombencephalon, that means hindbrain, where your brainstem is forming. Just next to it, there would be surface ectoderm, which is going to invaginate. It's not coming out from the neural tube itself. This is the hindbrain. This is the neural tube, which is forming the rhombencephalon, the part which is going to give rise to the pons and medulla. Just next to it, the surface ectoderm is going to start to invaginate. And this surface ectoderm, as it is going to invaginate, we initially call it otic pit, because it's a depression, so it's a otic pit. And then as it is going to further invaginate, it will detach itself from the surface ectoderm. When it is going to detach itself from the surface ectoderm, it is going to form a vesicle. This vesicle is called otic vesicle. So it is lying where? Just next to the hindbrain, which is the rhombencephalon. Now also imagine yourself and see where your internal ear is located. The brainstem, internal acoustic meatus, and then next to it is your internal ear. This is where it is located. So you can also see it here, rhombencephalon, which is going to give rise to your pons and medulla, and just next to it is this vesicle, which is called otic vesicle. It has arisen from the surface ectoderm. The surface ectoderm has invaginated, get detached, form a vesicle. Now it becomes a circular or spherical structure. So it's like a spherical structure like this. This is called otic vesicle. Now this otic vesicle will divide into two parts, a ventral part and a dorsal component. The ventral component will give rise to the saccule and the cochlear duct. The dorsal component is going to give rise to the utricle and the three semicircular duct. So this is what your membranous labyrinth. So your membranous labyrinth is all arising from this otic vesicle. The ventral part is going to give rise to the saccule and the cochlear duct. The dorsal part is giving rise to the utricle and the three semicircular ducts. And the mesenchyme around it is going to give rise to the bony labyrinth. So you have the membranous labyrinth, which has the endolymph, is arising from the otic vesicle, which is basically ectodermal embryo. It just came out from the surface ectoderm, divided into a ventral part, a dorsal part. Ventral part is giving rise to the saccule and the cochlear duct. Dorsal part is giving rise to the utricle and the semicircular ducts. The mesenchyme around it is going to give rise to the bony labyrinth. So this is membranous labyrinth, bony labyrinth. Internal ear, done. So you can see it here. This is the otic pit, which is just next to the rhombencephalon or developing rhombencephalon. It would invaginate, get itself detached from the surface ectoderm, giving rise to the otic vesicle. Next, we need to talk about the middle ear cavity because we have already the internal ear. How does the middle ear comes into the formation? So, if you remember, probably this week or last week, Paul might have talked about pharyngeal arches and pouches.
Last week.
Last week. So anybody can tell me about pharyngeal pouches? What are pharyngeal pouches, arches, anything you remember?
The first one gives rise to trigeminal.
Yeah, but what do you think about pharyngeal arches? What are the pharyngeal arches? Muscles growing.
Derivatives of the muscle.
Derivatives of the muscle. Anything else you guys can think of? So if you remember, there are these arches which are developing in the neck region of the embryo. Okay, and there are initially 6 of them, but we are left with 4. So these arches, on the outer side there would be ectoderm. The core is mesoderm, which is going to give rise to the muscles and the cartilages. And on the inner aspect of these arches is endoderm. Okay? So between the first and the second arch, there would be, on the outer side there would be clefts, which are ectodermal clefts. And on the inner side there would be endodermal pouches. Okay, so they are between the first and the second. On the outer side there is a cleft. On the inner side there would be a pouch. Now the clefts, because the second arch is going to overgrow and cover the third and the fourth arch. That's why you see your neck is all smooth on the outer side. There is no hole except one, which is this one. So the first cleft remains, which is between the first and the second arch, because the second arch is overgrowing the third and fourth. So your neck becomes smooth. The only hole left is this. So the first ectodermal cleft is going to give rise to the external auditory meatus. But the rest, you see a smooth neck because the second arch overgrows the third and the fourth. On the inner side, there is no overgrowth. So on the inner side, you have the first pouch, you have the second pouch, you have the third pouch, and you have the fourth pouch. They are all, the endodermal pouches are all there. First, second, third, fourth. The first pouch, which is between the first and the second arch, the endodermal pouch, is going to extend backwards. And as it is going to extend backwards, it is going to form something which is called tubotympanic recess. This tubotympanic recess, the proximal part of it is going to give rise to the auditory tube. The distal part of it is going to give rise to the middle ear cavity, and then the posterior most part of it is going to give rise to mastoid antrum. So you have this tubotympanic recess, which is basically the extension of the first endodermal pouch. And this first endodermal pouch, the proximal part of it is narrow, which is giving rise to the eustachian tube. Then the middle part of it is going to give rise to the tympanic cavity. And then as it moves forward, backwards, it is going to give rise to the mastoid antrum. So these all cavities, the eustachian tube, tympanic cavity, and mastoid antrum, the epithelium here is coming out from endoderm. Okay? So you have the inner ear coming out from the ectoderm, because it came from the surface ectoderm, get detached, forming the aortic vesicle, giving rise to saccular, utricle, semicircular canals. Your middle ear cavity is coming out from the first endodermal pouch, which is going to move backward as a tubotympanic recess. The proximal part of it is giving rise to the auditory tube. Then the middle part, the tympanic cavity, and the posteriormost part is going, or distalmost part is going to give rise to the mastoid antrum. Now you also have within the middle ear the three ossicles, the malleus, incus, and stapes. And as we said, that the muscles, cartilage, and bone are going to come out from the mesoderm in the arch. So the arch has outer ectoderm, inner endoderm, and there is also the core, which is mesoderm. So because it is coming at the junction, the pouch, the first pouch is between the first and second arch. The malleus and incus would come from the mesoderm of the first arch, and the stapes would come from the mesoderm of the second arch. Okay? So the three bones which you are basically getting, malleus, incus, and stapes. Malleus and incus coming from the mesoderm of the first arch, stapes from the mesoderm of the second arch. What is left in the middle ear cavity? You have the tympanic membrane, because which is, between the external ear and the middle ear. So first we will talk about the external ear, and then we will talk about the tympanic membrane. So everybody clear about the middle ear?
Doctor, what about the tensor tympani muscle and the?
So tensor tympani muscle again is coming from the first arch, because it is related with trigeminal, and the first arch nerve is trigeminal, and stapedius is coming from the second arch, and it is the second arch nerve is facial. So you need to remember this, because in the middle ear you have the junction of both the first and the second arch, because it's coming out from the second pouch, first pouch, which is at the in between the first and the second arch. So you would have the structures coming from the mesoderm of the first arch and mesoderm of the second arch. So the muscles which you are seeing, the tensor tympani coming from the first arch, the stapedius coming from the second arch, malleus and incus coming from the first arch, stapes from the second arch. The nerve of the first arch is trigeminal, and the nerve of the second arch is facial, and that's why their nerve supply is like that. Everybody clear? Okay. Now we are coming to the development of the external auditory meatus, and we said that on the outer side of these arches, you have the first arch, the second arch, the third and fourth, but because second arch overgrows the third and fourth, on your outer side you do not have any grooves. Your neck is pretty smooth. The only hole which you can see is external auditory meatus. It is coming out from the junction of the first and the second arch on the outer side, which is the first cleft, first ectodermal cleft, to give rise to the external auditory meatus. And initially you have an epithelial growth or meatal plug which is closing your external auditory meatus, because you don't want amniotic fluid to keep going inside there. So you have a meatal plug which is closing the external auditory meatus. At around 7th month, this meatal plug dissolves. If you do not have this meatal plug dissolving, then you have congenital deafness. So you need to see if the meatal plugs are gone or not at the time of birth, because around 7th month of intrauterine life, the meatal plug is going to dissolve by apoptosis, and you would have the opening of the external auditory meatus. Now, we are coming to the tympanic membrane, because tympanic membrane is at the junction of external auditory meatus and the middle ear cavity. Middle ear cavity, as we know, is endodermal. So inner side of the tympanic membrane, the epithelium is coming from the endoderm. External auditory meatus is coming from the ectodermal cleft, first ectodermal cleft. So the outer side of the eardrum would have ectoderm. So towards the external auditory meatus, the epithelium is ectodermal. The one which is facing the tympanic cavity is endodermal, and in between the fibrous part of the tympanic membrane is mesenchyme. So you have ectoderm, mesenchyme in the center, and endoderm on the other side. So the epithelium, which you would see on the outer side, is squamous, mainly ectodermal in origin. The epithelium on the inner side facing the tympanic membrane is simple columnar because it is endodermal. And in between you have fibrous tissue in the tympanic membrane, which is mesenchymal in origin. So there are three layered structured ectodermal epithelial lining from the floor of the auditory meatus, endodermal epithelial lining from the tympanic cavity, and intermediate layer of connective tissue, which is mainly mesodermal in origin. This is how the tympanic membrane is formed. And that's why you would see maybe also in the wall of where the tympanic membrane is forming, you have all three arches coming together, the first, second, and the third. So all three nerves, auriculotemporal, branches of facial, and vagus, are contributing to the nerve supply of the eardrum, because all three arches are coming and fusing at this particular point. So this is just showing you the different structures we have already talked about, that cochlea, saccule, are basically coming from the ventral part of the aortic vesicle, and then you have the utricle and the three semicircular canals, which are coming from the dorsal aspect of the aortic vesicle. The tympanic cavity coming from the first pharyngeal pouch, which is called tubotympanic recess, and then the external auditory meatus is coming from the first ectodermal cleft. So if you remember this, you would remember the other thing which people would keep on asking you is the malleus and incus coming from the first arch, stapes from the second arch, tensor tympani from the first arch, stapedius muscle from the second arch. So these are these things which people will keep on asking you in different forms in the examination. Now what is left is this, your auricle. We have talked about the external auditory meatus, we have talked about the tympanic cavity, we have talked about the internal ear. The only thing which is left is the auricle. So auricle develops from 6 mesenchymal proliferations at the dorsal end of the first and the second pharyngeal arches surrounding the first pharyngeal cleft. These swellings, there are 6 swellings, they would join together and they are going to give rise to the auricle. Initially, the external ears are in the lower neck region. So your external ears are here in the neck region, they are not here. But as your head and the mandible is going to grow, this would move upward and come towards the side of your head. So initially they should be, if your these bones are not going to grow, your ears will not go up. But because as the mandible and everything is going to grow, your ears will come towards the side of your head. So this is, with the development of mandible, they ascend to the side of the head at the level of the eyes. So initially they are in the neck. That's how you should understand that pharyngeal arches are in the neck. They are not in the head region of the embryo. But as your mandible is going to grow, there is a relative ascent of your ears to the side of your head. Congenital abnormalities. So congenital deafness, often with deaf and mutism. So if you are deaf, you might be mute also, because you cannot, if there is a congenital deafness, you cannot hear anything. So how would you learn the language? So deaf and mutism are usually together, caused by abnormal development of membranous and bony labyrinth. So mainly the congenital deafness, the major cause would be abnormalities in the development of membranous labyrinth, which has mainly the organ of cauti, and organ cauti is important for hearing, and nerves and everything is there. Or malformations of ossicles, if the malleus and incus are not formed well, or there are problems with the eardrum. In extreme cases, tympanic cavity and external meatus are absent, but this is very, very rare. Majority of congenital deafness is because of abnormalities in membranous labyrinth or malformation of ossicles and eardrum. External ear defects of the auricle are pretty common. You would see different deformed cartilages, which range from minor to severe. So you can have periauricular appendages, skin tags, anterior to the ear, preauricular pits, depression anterior to the ear. All these are the different types of abnormalities which you can see on the external ear. So you can see it here. You see these are appendages. See, this is, this is an appendage, protrusion. Yeah.
Doctor, did they have a problem with like localization of sound or anything?
Nothing.
Nothing?
No.
It's
Yeah, it's just a deformity of the ear, more of a cosmetic issue. Or they might indicate some other congenital abnormality. So sometimes you have deformed ears, which are not going to cause deafness, but they are going to give you an indication of another congenital abnormality. You see these pits, these are the pits, these are different appendages of the external auricular canal. Then we have this Treacher-Collins syndrome. Now, Treacher-Collins syndrome is where your first arch is not developing. Why? The mandible is not developing. So if your mandible is not developing, you know that this is a first arch defect. Now, if you remember, first arch also gives rise not only to mandible, but it is also going to give rise to the malleus and incus. So if malleus and incus are not going to be formed well, then you have deafness. So these guys would have underdeveloped cheekbones, microganthia, which is a small jaw and chin, cleft palate sometimes, downward slanting eyes, eyelid glaucoma, absent malformed ears, hearing loss in 50% of the cases, but normal intelligence. There's nothing wrong with their brain. So Treacher-Collins syndrome affects the development of bones and other tissues of the face. Signs vary greatly from almost unnoticeable. So this is a mainly first arch problem. If the first arch is not developed well, you will not have the mandible developing well, you have the malleus and incus affected, and you would have some facial bones not made well, cleft palate. Severe cases, undeveloped facial bones may restrict an infant's airway, causing potentially life-threatening respiratory problems. Ocular findings, downward slanting eyes, sparse eyelashes, eyelid glaucoma. Some have additional eye abnormalities leading to vision loss. Ear absent, small or unusually formed, hearing loss in 50% of cases caused by defects of the three middle ear ossicles, especially the malleus and incus, and underdevelopment of the external auditory meatus, which is the ear canal. Intelligence is usually normal. Thank you very much. We'll stop here.